Bonjour and good afternoon. Welcome to WASA Distance Education Center and PLAR Science. So today, or this afternoon, this is our last PLAR Science for week 9. This is our 17th class. A couple of announcements. Don't forget that the WASA graduation is happening on Tuesday next week, June 18th at the Sioux Lookout Legion, starting at 1:30 p.m. So if you are planning to attend, just keep that in mind. It is on Tuesday, June 18th, Sioux Lookout Legion at 1:30 p.m. It's not too late to apply for term 3, so we have a summer term for June 24th to August 23rd, so that's 9 weeks of classes. And the summer courses available for these classes are English, Math, Science, and History. So if you're looking to work on your college English or workplace English, we have several courses: NBE 3C, ENG 3E and 4E, so you get the workplace grade 11, 12 English. We do offer the grade 12 college English, ENG 4C. Also, if you were interested or needing the grade 12 University English, we do have ENG 4U, and of course the literacy course, the OLC 4O. For math, we have grade 11 and 12 workplace math, MEL3E. MBF 3C is the grade 11 college math, personal finance. Grade 12 college math foundations is MAP 4C, and the grade 12 college math technology is MCT 4C. Under the sciences, we have grade 10 applied science, the grade 11 workplace environmental science, which is the SVN 3E. SBI 3C is your grade 11 college biology, and we do offer college chemistry in grade 12, which is the SCH 4C, and grade 12 university biology is the SBI 4U. For history, we have grade 10 applied history, CHC2P, and the workplace native studies, NBV3E, and we are offering the cooperative education DCO 3O. Also stay tuned, we will be having the term 2B draws, I think tomorrow afternoon, but we'll let you know. So the two students, we will have 2 student draws, one for students who earned a credit, and then one for students who submit work. So if you've been submitting work beginning April 15th, which is the beginning of week 1 for term 2B, so if you finished a course, or if you did PLAR and you finished that component, your name will go for that earning a credit section, and then students who have been submitting work, your name will be going under that section. So make sure that you stay tuned. We will be letting people know probably on our WASA page, or maybe your DEC will post it on their Facebook page. Okay, just a reminder, since the deadline is today for submitting work, we will not be having PLAR marking over the summer, so that means that PLAR Science, PLAR History, Geography, PLAR English, and PLAR Math. So if you're working on your courses or on your components for PLAR, you can still view the classes. So for myself, you can go to J. Mercer WASA on YouTube. If you go to the playlist section, then you can choose which component you want to work on, whether the PLAR Science, the PLAR Geography, PLAR History. And if you type in B. Osmond WASA, there we go. So you can check out her videos. So she has under her playlist, she has the PLAR Math and the PLAR English. So that will stay up over the summer if you are interested in working at your PLAR components. So for our last class, we will finish up with lesson 5, environmental science, and then I will go over the culminating activity for the PLAR science. Once you receive your culminating activity, make sure you complete it as soon as you can. Or if you still have it now, again, the deadline to submit it will be today. So make sure that you return it to me so that you can get your equivalent credit. And you must get 50% or over, okay, in order to pass. So we did as far as key question 77 for lesson 5. So we only have 3 more key questions left to complete, and then we're done with the PLAR science, and we will look at the culminating activity. So our last topic is on pesticides. So if you look on page 16 of your lesson book, so there's your heading, pesticides. So there is no better way to understand the flow of matter through an ecosystem than to study the food web. So remember, we looked at food webs and food chains. So the food webs consist of, and if you look at on page 20, there's a list of, there's answers to support questions on page 20. So it tells you in column A all the different terms, so abiotic, artificial, biodiversity, and so on. And then if you turn to page, just show it to you here, on page 6, and you look at the food web on page 6, it shows you that it consists of many food chains. So remember, the food chains is just a step-by-step sequence. So you might start with the grass, then the grasshopper eats the grass, frog eats the grasshopper, the snake eats the frog, and then an eagle eats the snake. Okay, so that's just a step-by-step sequence, and it links in organisms that feed each other. Whereas the food web, you have many food chains, and it shows all the interconnections between organisms. So you might have humans there, you might have an eagle, trout, dragonfly, frog, snake, plankton, and then it shows you the many chains or the many webs. So you might have the human eats the trout, but the eagle eats the trout. The dragonfly is eaten by the trout. The frog is eaten by the snake. And then the frog eats the fly, and so on. So you see, it's just not one straightforward flow, but a web. So when we look at the food webs, we also see that there's natural organic matter that's traveling through each trophic level, and also toxins. Now, toxins are poisons, and they're introduced by humans. So one of the poisons that have been introduced by humans are pesticides, and these are chemicals designed to kill pests. A pest is an organism that people consider harmful or inconvenient. For example, weeds, insects, fungi, and rodents are considered pests. Pesticides are used to protect species that are beneficial to humans from a competitor or predator that is less useful. So why use pesticides? Well, several reasons. Pests destroy weeds, rust, molds, insects, and small birds, making the cost to consumers staggering. Also, certain pests, they also pose a threat to human safety. Here's a common example, is the mosquito, which in tropical areas may transmit the disease. And that should say malaria, not mosquito. Okay, and I think I'll just fix it right here. that in there now so that I don't forget. Okay, another reason is that by using pesticide, it combats or kills pests in homes, places of business, schools, parks, hospitals, and other public places. So you can see pictures on the bottom of the slide there where pesticides are being used. The first one shows where you have a farmer using pesticides on his crops. Here's a form of pesticide that looks like ants, so killing insects. Pesticides used on, could be in your backyard. That one looks like it's flowers. And then you have even plain spraying pesticides, and again that shows being sprayed on crops. Okay, so pollutants and the food chain. So human activities can make natural disturbances much worse. Introduce synthetic. Now when you hear synthetic, that just means human-made chemicals into the environment. So here the picture shows you this person is using pesticide. So he's spraying it, okay, on the grass. Now the toxins from the pesticides or pollutants now goes into the grass, which the cow eats. Okay, the cow produces milk. Now there's some of that pollutants in the cow. The cow spreads it to the milk, and then you have the person who's drinking the milk will also be ingesting some of those toxins. First generation pesticides. Well, many first generation pesticides such as sulfur, arsenic, and lead were used to kill insects. But farmers discovered that these substances were not only hazardous to insects, but they were also harmful to humans. In 1763, the use of nicotine sulfate, which is a chemical from the tobacco plant, was used to kill aphids. Now, the first generation pesticides were primarily natural substances. So we had sulfur, lead, arsenic, mercury, and also plant extracts were used, nicotine and pyrethrum. So the natural chemicals or botanicals borrowed from plants that had been defending themselves. Okay, so keep that in mind as the first generation pesticides. The second generation pesticides, these were made in labs or laboratories. They are no longer plant extracts. So in 1939, the first potent chemical known as DDT was created. And DDT stands for diphenyl trichloroethane. And this was meant to control mosquitoes, but they were banned because of biomagnification. And we will look at that term. So this lethal insecticide changed the practice of chemical control forever. So first off, what is DDT? So we said that DDT stood for that very long word, so diphenyl trichloroethane. It is the most commonly used and well-known pesticide in the world. It was created in 1873. It's created by the reaction of trichloromethanol with chlorobenzene. The chemical formula, so if you remember when we talked about chemical formulas, it was C14H9C15. In its pure natural form, DDT is a white crystalline powder with minimal odor. So how is the second generation pesticide different from the first one? It's primarily synthetic. Remember, synthetic means man-made. Organic compounds. It uses a broad spectrum agents, so toxic to many species. It has a narrow spectrum agent which is toxic to few species, but its persistence is in the environment. So if you look at the first generation pesticide application, the top half, so you can see there are two sets of leaves, or two leaves. Before the pesticide application, you see one red bug and you see 8 white ones. After the pesticide is applied, you have the one bug left and you have 2 of the white ones left. The later generation pesticide application shows that you have 4 of those red bugs and 4 of the white bugs. After the pesticide application, you get 1 of the white bugs left, but you still have 4 of the red bugs. Hence the narrow spectrum agent, meaning it's toxic to few species. Amplification, which I said earlier. So pesticides that contain chlorine, such as DDT and Dieldrin, what they found out was this was soluble in fats but not in water. This means that these toxins or poisons cannot be released in urine or sweat. So it builds up or accumulate in the fatty tissues of animals. So when we talk about amplification, it just refers to the large increases of toxins found in organisms at higher trophic levels. So let's say in this example here we have dioxins are released when plastics are burned. Okay, so it's showing you burning of plastics, and the toxin that we're talking about is dioxin. So notice the dioxin level that goes into the crops. Okay, you see it as 1. Now the cow eats the crops, or say the grass. The dioxin level for the cow is at 2. Okay, so now it's accumulating. Okay, this person eats, say, I don't know, ground beef or a hamburger. The dioxin level is now at 1, 2, 3, 4, 5. Okay, and then this woman produces milk and she breastfeeds her baby. Now the baby has 1, 2, 3, 4, 5, 6, 7, 8, 10. So as it goes up, the bioaccumulation and biomagnification of dioxins increases. Okay, same thing. Here's another example for bioaccumulation. So you have a small amount of pesticide in the environment, just like we saw there for the crops, and they will enter the bodies of animals that are low in the food chain. But as you go up the food chain, the amount of toxin becomes much worse, because each predator eats much prey. So with each process is referred to as bioamplification or biomagnification. So chemicals are passed on as they are eaten and digested. Okay, so think about with each increased trophic level, the concentration of the toxins or poisons become greater. The bioaccumulation is just a gradual buildup of chemicals in living organisms, and it happens when chemicals are taken up or they're stored faster than they can be broken down or excreted. They can be absorbed through food, skin contact, or respiration. So here's an example for bioaccumulation for mercury, DDT, and lead. So you have these two people fishing. There's lead or DDT or mercury in the water. So you can see that the loon there So you see the red circle, so they have, the loon has a lot. The smaller fish, or the fish, have less. That looks like weasel or muskrat has eaten the fish, so now the accumulation for that predator is higher. And then you also have the bird that looks like a kingfisher eating the fish, so again the accumulation there is higher. Okay, so the red shows you that's the mercury, DDT, and lead present, okay, in the environment. Another way to look at it is if you look at, say, the water level, or the amount of toxins in the water is at 0.000003, okay, per million, so the DDT concentration parts per million. In the zooplankton, there's 0.04 ppm. Then as you go up, so the small fish will have 0.5 ppm. The larger fish has about 2 ppm. And then the osprey, or the bird that eats the large fish, gets 25 ppm. So that shows you the higher up the food chain, the more concentrated the pesticides become. So the effects on human, well, like other top predators, humans are subject to bioamplification. So evidence that DDT was beginning to accumulate or collect in humans was known in the 50s and 60s, especially in humans who lived near where DDT was sprayed on crops. So in 1971, DDT was banned in Canada, and then the US followed suit in 1972. DDT is toxic to a wide range of animals, in addition to insects, including marine animals such as crayfish and prawns and many species of fish. It is less toxic to mammals, but may be moderately toxic to some amphibian species, especially in the larval stage. So DDT and DDE have also been known to be linked to diabetes, neurological problems, cancer, and decreased fertility in males. Okay, up next, modern chemical pesticides. So modern pesticides are not stored in fat tissue. So unlike the previous pesticides, these are soluble in water, meaning that animals can remove them from their bodies by breaking them down in their livers and excreting them. These new compounds operate like nerve gases. That means they act by preventing electrical messages from traveling from the brain to the muscles that control breathing or the limbs. They either kill animals directly, or they make them vulnerable to predators. So here are some types of pesticides. About 900 active ingredients in 20,700 products are currently sold in world markets. So you might have heard of some of these. Insecticides, okay, obviously kills insects. Fungicides kill fungi. Herbicides kill weeds. Nematicides kill nematodes. Rodenticides, they kill rodents like mice or rats. Molluscicides kill mollusks like snails or slugs. And microbicides, they kill microbes. But there are 3 problems of modern chemical pesticides, okay, and they include the following. So these new chemicals are not selective, because the nerve action of most larger animals is very similar. It means that these insecticides are capable of killing mammals, birds, reptiles, amphibians, and fish. And because they are water soluble, that means they can break down more quickly, which means they have to be applied to crops on a more regular basis. And finally, animals that have died or have been weakened by the toxin put any other animal that eats them at risk through bioamplification. So large doses of these pesticides can still cause death. So here you have a picture of species of predatory birds, including osprey, bald eagles, and peregrine falcons, declined in numbers because DDT bioaccumulated in their bodies. Okay, so the pest fights back. So pests gradually become resistant. That means less likely to die from pesticides. When a pesticide is sprayed for the first time, approximately 10% survive. So surviving insects may have genes that help them survive the application of the pesticide. The surviving insects also have the benefit of less competition for food. So in addition, they will be passing these pesticide-resistant genes to their offspring, providing them with a strengthened immune system. So once insects become resistant to a pesticide, then chemists must search for a new poison. So here you have, so there's 10 insects there. By having 10% resistant, that means one of those pests will not die. Okay, and that's it for this section. So we will complete our key questions. We only have 2 left, or actually 3 left. Key question 79. It says in 1939 DDT was potent insecticide and could be used to kill pests such as mosquitoes. What was wrong with this technical solution? So remember, the key word here is what was wrong with using DDT. We know that DDT and Dieldrin, okay, we're not soluble in they were soluble in fats but not in water. Let me just fix that. Were soluble in fats, okay, but not in water. And that just means that they can't be released by sweating or excretion. Okay, so releasing in urine or sweat. So what happens? What is bioamplification? So if you can't release it, or if the toxins pile up, so bioamplification, amplification, and we just looked at that. So if you're not sure which page, so the higher up the food chain, the more concentrated the pesticides become. Okay, that process is called bioamplification. Okay, finally, identify and describe the 3 dangers of modern chemical pesticides. So these are outlined for you in your book. There's 3 of them. And again, if you're not sure where you can find that, it tells you right at the end here. The 3 problems of modern chemical pesticide. We said the chemicals are not selective. Because they are water soluble, that means they have to be applied to crops on a more regular basis. And then animals that have died or have been weakened by the toxin, it puts any other animals that eats them at risk through bioamplification. Okay, so these are the 3 problems of modern chemical pesticides. Okay, so if we look at our mark sheet, if you look at all the way up here, we have now completed key questions 79 and 80, which means that if you have completed these successfully, then you are now ready to do the culminating. Now this is what the culminating activity looks like. It has a set of instructions. So remember, this is not a test. However, it does replace the test, and you must get a passing grade. Okay, and the passing grade is 50% or over. So if you get under 50%, that means you are unsuccessful. Students who complete the 5 lessons successfully are eligible. That means you can write the culminating activity. So more than likely you will get something like this. So that's student's name, Sioux Lookout, PLAR Science. It shows my name there. It tells you that the student did very well in lesson 1, did well in lesson 2, 3, 4, and 5. The marks were pretty consistent. Then I will give that student the culminating, and then they will complete it and return to me for marking. When you get your culminating activity, you may use your notes, lessons, and marked key questions, which I scan and email back to you to help with the task. If I don't email back to you, it also means I'm probably send it on the express. Answers must be original and written in complete sentences. Answers may be written in the spaces provided if you like, or you can type it up and send it to me. When you get your culminating, check to make sure that no pages are missing or out of order. It's best if you read through the entire set of tasks before starting the assessment. No time is specified for completing the culminating activity. That means I don't give you 2 hours once you start. You can spend the time you need to complete it. If you have difficulty with the task, so if you're concerned about the question, if you're not sure what I'm asking you to do, move on to another and then come back to the missed task later. If you still don't understand it, contact me. Again, read the question and the directions carefully. When answering questions, just use the information provided as well as your own knowledge and experience. For example, if I say in your opinion, okay, that means you're using your own knowledge and experience. You do not need to use, you don't need to do a Google search to find the answers. It's there in your culminating activity. So this is what it looks like. Make sure right away you put your name here. Put the name of your community. And then the next line, I will tell you what you got out of the 100. There are 5 sections in the test. The first section is section A, and in that section, it's all about chemistry. In section B, it's about biology. Section C is astronomy. Section D is physics, and the final section is environmental science. And like I said, you do not require Wi-Fi or internet access to do the culminating. Okay, everything is in there, what you need to complete it. So doing the section A, this is what it looks like. It shows you paragraphs of information. Pay attention to the heading, because the heading tells you what the paragraph is about. So classification of matter. It says here, chemistry is the study of matter. Matter is a scientific term for substances that make up everything in the universe. All matter, whether it is solid, a liquid, or a gas, or whether it is visible or invisible, is made up of small particles. Then you will notice that there are words that are bolded. They are darker than the rest. The word molecule, for example, is darker. It says when two or more atoms are joined to each other to form a more complex particle, the particle is called a molecule. So that's the definition of molecule. You can mark up your culminating. You can use a highlighter if you want to say, hey, that one is for molecule. I'm going to highlight that because now I know that that's part of a definition. Another one, I see another one. When a substance is composed of only one atom or one type of atom, it is called an element. For example, if all the atoms in a substance are carbon atoms, then the substance is the element carbon. Here's another one, compound. It says when a substance is composed of one type of molecule, and the molecule is composed of at least two different types of atoms, it is called a compound. So just by reading the first page of the culminating, I have found 3 definitions or terms. I'm just going to show you here. Let's view this on a dual page. So there's a couple more pages there, but the first section for chemistry, it says use the following terms to fill in the blanks. So A to K. It says the blank is considered the basic building block of all matter. But remember, when we looked at page 3 of your culminating, we found the word compound, element, and molecule. Okay, guess what? These are all here too. Molecule, compound, and element. So number 8 says a blank is composed of only one type of atom. And then while a blank is composed of only one type of molecule. And then another one here says 2 or more different types of atoms bond together to form a single particle are called. Okay, so if you're looking at that, some of these, when you're reading the information on page 3, you can tell right away that, hey, I know the answer for the one that says compound. Okay, when a substance is composed of one type of molecule and the molecule is composed of at least 2 different types of atom, it is called a compound. So number 9 is compound. Okay, and number 8 is element. Two or more different types of atoms bond together to form a single particle are called, so if you look back here, 2 or more atoms are joined to each other to form a more complex particle. We know that one is a molecule. Okay, so that's all you have to do for your culminating. You're reading the information. The next section shows biology. So in biology, it talks about cells. Again, look at the heading. The word cell is in bold, so is cell membrane, nucleus, cytoplasm. For section B, biology, you match the terms with the most appropriate statement below. So it shows you the words chloroplast, ribosome, cell membrane, lysosome, etc., right up to Golgi bodies. The description is on the right. It says manufactures proteins, packs and stores materials that are to be secreted by the cell, found only in plant cells. Okay, semi-permeable structure that surrounds the entire cell contents, everything inside the cell membrane except the nucleus, and releases energy for use by the cell. It says here that cytoplasm is found inside a cell. The cytoplasm is everything inside the cell membrane except the nucleus. The liquid part of the cytoplasm is made of water with other kinds of substances in it. Many of the life functions of the cell take place in the cytoplasm. So I know that it says here it's found inside the cell, everything inside the cell membrane except the nucleus. So it's a semi-permeable structure that surrounds the entire cell contents. Okay, so that's the cytoplasm. Okay, section C talks about astronomy. Make sure that you know, okay, the order of the planets in order from the sun. Remember how we came up with a clue? So for each letter of the planet, so M is for Mars, V is for Venus, E is for Earth, M is for Mercury, J is for Jupiter, U is for Uranus, and N is for Neptune. So if you do that, you can say M for my very eager mom, just, so J served, S, U, us, nachos, N, and then you would just fill it out. So Mars, Venus. Because if you get one wrong, then more than likely the others will be wrong too, because now you have the order wrong. The other section is to match each fact to the name of the planet. So look at this one. Notice there are 4 marks because it says these 4 planets are often called gas giants. Don't just name one of the gas giants. It says right here there's 4 of them. It is the smallest inner planet, it is the closest planet to the sun, and so on. So everything else is 1 mark except for the first one where it says these 4 planets. So if you only name one, then you only get 1 mark. Okay, physics. Read this carefully. And then based on your knowledge of electrical charges, fill in the missing spaces. Where it's numbered, that's where you need to put in your answer. So it says if the charge on the, and this is the example, if the charge on object 1 is neutral, the charge on object 2 is negative, then does it attract or repel? It's attracting to it because based on the 3rd law, neutrally charged object will be attracted to a charged object. So if it's neutral and you put it beside an object that is negative, they will attract. So your question here is what will be the charge of object 1? If the charge on object 2 is positive, will it attract or repel? Okay, so if you put positive, and this is just an example, and you put it beside a positive, will it attract or repel? The answer is repel, because like charges repel. And then finally, your last question or section is in environmental science. So with this section, Most of it is reading the information. It says experts in climatology and other scientists are extremely concerned about the changes to our climate. Admittedly, the climate changes have occurred on our planet before. For example, there have been several ice ages or glacial periods. These changes were different from the modern ones because they occurred gradually and naturally. The current changes, like what's happening now, aren't the result of natural causes, but of human activity. Furthermore, the changes are occurring alarmingly rapid. That means it's happening faster. So question 15 says, what climate changes have taken place? Now this is the key word here, before the present time. So reading that first paragraph, based on what we have just read, it said that yes, there have been climate changes, but what has taken place before the present time? Okay, so read that carefully. And then question 16 says, what are the main differences between modern climate changes and the ones that occurred in the past? So what's different with the climate changes now and the ones that happened before? Okay, it says right here, the current changes aren't the result of natural causes, but of human activity. So remember, before the changes were happening gradually and naturally, but not anymore. The modern climate changes are due to human activity, and it's happening at a faster rate. Okay, then the second paragraph talks about the major problem is perhaps that the planet is warming up. According to some experts, this warming, known as global warming, has been occurring in the last 10,000 years, okay, and so on. So question 17, what were the agreements reached in the summit in Tokyo? Okay, that's in further reading. Which suggestions were made and why? In your opinion, that means I'm asking you, is global warming true or false? So if you believe it's true, you say true, and it says give reasons. So you might say true because, okay, and provide your reasons. If you don't think it's true, then you write false. But you have to give me a reason why you believe or think that it's not true. And then finally, the last question, it says, list 3 things you can do. That means you. So the answers here will vary. So if I'm answering these questions, list 3 things that I can do to reduce global warming. Well, maybe I should walk more and drive less. That means I'm using my vehicle, emitting less fossil fuel in the air. Like when I start the car, there's gas fumes and so on. Maybe I should turn off lights, okay, when I'm not in the room, so on. Yeah, or use appliances that are environmentally friendly, and so on. Okay, and that's it. That's the 5 sections of the culminating activity. So when you are submitting your culminating activity, same thing when you're submitting your work, you can get your DEC to fax it, you can scan email it to student work, you can use your notes app to scan email it, you can send a picture through Messenger, and so on. Okay, and that's it for PLAR Science. Again, a reminder that our graduation is on Tuesday, June 18th. It's happening at the Sioux Lookout Legion, beginning at 1:30. So I hope to see you then if you're attending. Miigwech.